Welcome to this channel Chemistry Made Easy by Dr. We were discussing the molecular orbital theory, in which we have seen last time different molecules such as heteronuclear diatomic molecules, and the examples were carbon monoxide and HF. Now we will see this third molecule, that is nitric oxide. This nitric oxide has atomic number 7 and oxygen has atomic number 8. The electron configuration of this nitrogen, that is 7, is 1s2, 2s2, 2p3, and this oxygen has 1s2, 2s2, 2p4. So we are considering here only this valence chain of this nitrogen and oxygen. This molecular orbital diagram is constructed by using this only valence chain of nitrogen and oxygen. We are not taken here the inner orbitals, that is inner shells like 1s of both atoms. The 2s and 2p is provided in the valence shell by nitrogen. It contains, 2s contains 2 electrons, 2p contains 3 electrons. The energy of this 2s of nitrogen is minus 25.56 electron volts. The energy of this 2p is minus 13.18 electron volts. Similarly, here it is 2s and 2p of oxygen. 2s has energy minus 32.38 and this 2p has minus 15.85 electron volts. This 2s contains 2 electrons and this 2p contains 4 electrons. Now, by linear combination of this 2s and this 2s, it gives 2 molecular orbitals, that is 2 sigma and 2 sigma star. Or in other words, we can say this 2s of sigma g and 2s of sigma star u. Similarly, the 2p of nitrogen and this 2p of oxygen undergoes linear combination and produces these molecular orbitals. The pz overlap linear combination produces this 3 sigma, or we can say 3 sigma g bonding molecular orbital, and this 3 sigma u star antibonding molecular orbital. The px and py orbitals of both atoms undergoes linear combination and produces 4 molecular orbitals, out of which these 2 are pi molecular orbitals of bonding nature. These are named as pi 1 pi and 1 pi. And the another are 2 antibonding molecular orbitals, 1 pi star and another pi star. Now whether 2p electron provides 2p provides 3 electrons and this 2p provides 4 electrons. So now there are 7 electrons, out of which 4 are placed in pi, 2 are placed in 3 sigma, that is bonding, and 1 is placed in antibonding pi molecular orbital. That is why it has the bond order, if we calculate, it is 1 So we can cancel these 2 electrons for these because bonding effect is equivalent to antibonding effect. Then there are these 4 electrons and these 6 electrons in bonding, 1 electron in antibonding. So the bond order is 2.5. So this nitric oxide has bond order 2.5, means it has the bonds 1 sigma plus 1 pi plus 1 half pi. So this pi gives the bonding effect of 1 bond, pi bond. This gives 1 bonding effect, that is pi bond. this gives one sigma bond, and this one electron removes any of the pi bond producer to 0.5 extent. So it gives 1/2 pi bond. So in this way there are 2.5 bonds in this NO. So there is also this photoelectron spectrum of this nitric oxide. So there are the values of these states or peaks starting from the 16 to 24. So these are comparable to these energy values. So we are having shown these states, means energy levels, according to these also. Means these are correlated to each other. So this is also called the comparative state. So here we find that the line like this, He produces this line. So this also gives the vibrational structure. It is not electronic structure, but it is vibrational structure, and it is a part of the electronic structure. So this line, the peak which is appearing at about 21.7 electron volt, it is appearing at 21.7 electron volt, just at low energy. It is arising due to the stronger sigma character, S characters, stronger 2S characters. So we have assigned this peak. Now, another thing you have to remember that the energy difference between the 2s and this 2s is not same. It is larger. So you will find that there is energy difference. So oxygen 2s is shown at lower energy and nitrogen 2s is shown at relatively higher energy. This 2G bonding MO is like this, more like this, means 2 sigma has more characters like this 2s of oxygen, whereas this 2 sigma star has more characters like that of this 2s of nitrogen, and that is why they are lying closer to each other. Further, in this case, you will find that these are bimolecular orbitals. So they are showing here, and there are some more here fine line structure in the photoelectron spectrum, and that is most of that appears as a vibrational characters due to the vibrational structure, means vibrational transitions. And here you will find that this A3 sigma plus is corresponding to this 3 sigma. So we have shown this 3 sigma having photoelectron spectral lines at this region, and another is there is this pi star. So there is no such, there are no lines for these antibody molecular orbitals. Here we have to remember that the sigma molecular orbital is lying at higher energy than this pi molecular orbital. So pi molecular orbital is at higher energy, means it has relatively low ionization energy. Further, this is called a HOMO, means highest occupied molecular orbital, because it contains 1 electron, and this is a LUMO, means lowest unoccupied molecular orbital. There is no electron. So we can have these molecular orbital order. So this order of molecular orbital, whereas we can find the bonding this 3 sigma, and this separation is also larger. Similarly, the important observation is that sigma molecular orbital lies at higher energy than the pi molecular orbitals. So this is one of the important observation. So this AA indicates the lines are appearing due to the He1 line, so which is used as a source of this photon. So here you will find that this B prime 1 sigma plus is one relational structure isoelectronic with carbon monoxide and nitrogen. So there is also similar observation, that is He1 line is here also observed. So in this way here you will find that these lines, that is C3 pi and B1 pi, these structures shows, or the peak shows strong peak appearing for 2s characters. 2s characters are designated by these two peaks. So there are actually two peaks. It is shown here like a single line, but these lines are overlapping with each other. But these are corresponding to the 2s characters. So with this we can say that this molecule has one unpaired electron in the pi antibody molecular orbital, therefore it is paramagnetic, and therefore it is also reactive. So photoelectron spectrum is supporting to this molecular orbital structure. So we will stop our discussion here. Please subscribe to this channel and press bell icon and like button. Thank you very much.